Don't try this at home, please. We think we're professionals. I'm James CH95 from Chief Delphi. I am here today with two friends. We're going to do destructive testing on the 2013 kit of parts plastic air tanks. Now, we know that there have been several failures of these. We're not here to test failure mechanisms. We're here to test mitigation. There have been some solutions proposed on Chief Delphi, most of which are probably inadequate, but that's what we're here to test. So the first thing we're going to do is explode a tank by itself with no mitigation. Next, we're going to try the bumper fabric solution. Third, we're going to try gaffer's tape or duct tape. So the first thing we did before running these experiments was find a paper about blast energy and blast containment. Calculated the energy in one of the plastic tanks as about 350 or 360 foot-pounds of energy. In the paper they described shrapnel danger for a 500 foot-pound explosion being about a 12-foot radius. So we are testing well outside of that range, and we'll be using eye protection and hearing protection during our test. Our detonation mechanism of choice is the RWS 34 model air rifle. We're going to be using it with 22 sized air rifle pellets. The idea behind using this is that it has only 50 pound-feet of energy at the muzzle. We didn't want to introduce any more energy than we could possibly stand, and this seemed like the easiest and most reasonable option. So here we are at our test range. We have the air tank here. It is not pressurized right now. It's hooked up to an air hose that we are going to be able to, so we'll be able to charge it remotely from inside my workshop. It's on top of a dead laptop because, hey, why not? We're going to blow that up too. We're going to be recording it with a GoPro approximately 6 feet away and another camera approximately 20 feet away. So, test conditions. You can see there's snow on the ground, but it is about 45 degrees right now, so we are within the rated temperature range of the air tank. It's connected to a 1/4 inch inner diameter air hose, which is bigger but very similar to the hoses used on FRC robots. It's going to be connected to 120 psi from my shop compressor, and we'll be connecting that with a quick disconnect fitting up inside the shop, so no one will be near the tank while it's charged. So this is our point of detonation. You can see there's not much of the tank left. We found a few pieces of shrapnel, though most of them disappeared entirely. Our first one is about 30 feet away. Is that large chunk of plastic there. Next to it, we have another piece of plastic. It kind of knifed its way into the snow. You can see that's nice and sharp and scary looking. We have another piece of plastic at the top of the bank. Over here. It comes right here. We have some smaller shrapnel, maybe 20 feet away, 15 feet away. Up here, we have larger pieces of shrapnel all the way, maybe 40 feet away from where the tank exploded. Anything else we can't really see. Gorilla tape, because I don't have gaffer's tape or duct tape, wrapped around the tank, approximately 2 to 3 layers thick. We'll see how well that does at containing shrapnel. You can see the tape failed horizontally, the direction in which it's designed to be torn, so guess what? Tape that's designed to tear gets torn and doesn't really do a good job of containing shrapnel. So after the tape detonation, we're actually able to recover basically every single piece of the tank. However, it's still fractured, but there was much less shrapnel.
I guess it's debatable what's better. Lots of tiny, lightweight pieces of shrapnel, or a couple very large, heavy pieces of shrapnel.
So for this test, we wrapped bumper fabric around the tank and then zip tied it in place. A few people, at least one on Chief Delphi, have suggested this as a possible solution, so we'll give it a try.
Still clear.
So, the zip tie and bumper fabric test. Tank still exploded. We got a lot of shrapnel. A lot of it was contained inside the bumper fabric. And while there's a lot of small pieces, our shrapnel radius is only 10 or 15 feet, as opposed to 40, 45 without any containment, and maybe 30 or 35 with the duct tape. So our next test, protecting or mitigating the blast with a bumper, we're using an old test bumper from '95. We used it to try different styles of painting numbers on. Constructed in the standard first way, you've got angle aluminum with screws through it and the fabric stapled to the plywood. It is robust, it's the right fabric. We've got a hole in it. We're going to drop the tank in thusly and then shoot it.
What?
Well, the bumper actually performed pretty well. We've got pretty much all the shrapnel in here as far as we can tell. However, it did cause all the angle to rip out for about the whole length of the tank on one side, and actually failed on the other side also. That is a lot of shrapnel.
That is an entire air tank's worth.
Imagine that.